All right, we need to solve the system of equations algebraically. Well, let's just remind you that we can solve this with substitution, right? We can take this thing right here. Sorry, that is too big. Take this part right here, and we want to substitute it. So negative 2 times 4y minus 25. At least this is what I would do. Minus 2y equals negative 10. All right, so we have different algebraic ways of doing things. Negative 8y, positive 50, minus 2y equals negative 10. Of course, we can subtract 50. Why, that 10 looks a little weird. Minus 50. It's supposed to be negative 10 minus 50. That'd be negative 60. And then over here, negative 10y. So we would divide by negative 10, and we would find out that y is 6. Okay, as I've said many, many times before, when you find part of your answer, put it in the answer so you don't accidentally put it in the wrong spot. And then you got to plug this back in. Obviously, you could pick at either equation. I would always pick the one that's already solved for, x or y, whichever one it was solved for. Plug it in. And then 24 minus 25 makes negative 1 for x. And so now we know the solutions in the system, negative 1, 6. So we can do other things like that, right? We can take this, substitute it here, giving me negative x squared plus 6x minus 7 equals negative 2x plus 5. I'm hoping that you see what I see. I'm going to be pushing these to the other side, adding 2x, subtracting a 5, setting this thing equal to 0, because I will have negative x squared plus 8x and a minus 12. So what are you going to do with that? Why did I set it equal to 0? So that I could use the quadratic formula, right? B squared minus 4 times the a value times the c value. So that's 64 minus 48, which is 16. And then we have opposite of b over 2 times a plus or minus the square root of, remember your discriminant goes underneath there, all over 2 times negative 1. So, of course, that's negative 8 over negative 2 is positive 4, plus or minus 4 over negative 2, that's negative 2. Now, quick question. Does that negative really make a difference? Because 4 plus negative 2, isn't that like 4 minus 2? Right? So one of your answers is 4 minus 2, and the other one is 4 plus 2. Well, that double negative turns into the plus version. Now, those are both x values. Neither one of those is a y value. You have to find the y value, which means you've got to take these values, go back up to here, and pick your favorite equation. Now, my personal favorite equation is that one right there, the linear one. So negative 2 times 2 plus 5. Negative 2 times 6 plus 5. Of course, my first one gives me what? 1. And my second one gives me negative 7. So those are my solutions to the system. So that takes care of that. Now, what do we actually have there? We have a line and a parabola, and they cross. Two equations, and one's obviously a parabola, and one is a line. So where do they cross? Well, there's that dot right there. Oops, sorry, let's try that again. That dot right there, and this dot right here. So that's 2, 1, and 6, negative 7, which agrees with the algebra that we did. So that's just a visual of what you're trying to do. All right, let's try our next one, right? We're going to stick this in here for this. 5x minus 7 equals x squared minus 7. And we're going to push everything over to one side, right? So, let's see here. We should subtract a 5x and add a 7. And so that would be 0 equals x squared minus 5x. Okay. So first part of the quadratic formula, b squared. Let's see here. B squared minus 4 times the a value times the c value. Now the c value you see is a 0, right? Because you don't see a value down here, so we know it's a 0. Therefore, I have 25. And then the second part of the quadratic formula, x equals opposite of b. Well, the opposite of b would be 5 over 2 times 1 plus or minus square root of 25 over 2 times 1. Okay? So we get 5 for one of them, right? Because you have 5 plus 5, which is 10 all over 2. I mean, I could have written it out like that, I guess. 10 over 2, which of course is 5. And then, of course, I get 5 minus 5. Oh, that's 0 over 2, which is 0. So my x's are 5 and 0. Now, what are the y's that go with those? Well, I would have to plug them back in. I usually like to use the linear function, 5 times 5 minus 7, 5 times 0 minus 7. So I get 25 minus 7 is 18, and the last one I get negative 7. So when I plug in a 5, I get 18. When I plug in a 0, I get negative 7. So these are the two answers for that question. Okay, so it looks like they want me to take this and plug it in for that. So 2x minus 2x squared minus 6x minus 8 equals 16. Looks like I'm going to have to distribute a negative 1. 2x minus 2x squared plus 6x plus 8 equals 16. Okay, we need to get everything all added together, all like terms added together, and everything put on the same side. Obviously, those two are like terms, so they can be added together. The 16 can be moved from this side over to this side, giving me a minus 8. And of course, this is just minus 2x squared. So now we have it set equal to 0, which is exactly what we wanted. So then we could do our b squared. So step number 1, b squared minus 4 times the a value times the c value. So let's see here. 64 minus 64 is a big old 0, right? So when I come to the second part, we've got x equals the opposite of b over 2 times a. Oops, that's a negative 2. 2 times negative 2 plus or minus the square root of 0. That's pretty boring. All over 2 times negative 2. So hopefully you know that that whole thing's going to become 0, because when 0 is in the numerator of a fraction, the whole fraction becomes 0. So we really have negative 8 over negative 4, which is 2. Now you're saying to yourself, well, Mr. Stailey, the other ones had 2 answers. This one only has 1 answer? Yeah, that's true. It only has 1 answer. And we can go back up there and we can figure out. Now, you can pick whichever equation you want. I'm probably just going to use that first one. Minus 1y equals 16. And subtract 4 from both sides, giving me negative y equals 12, and divide by the negative 1. And so y equals negative 12. Now let's see if it matches what happens when we graph it. Now what you can see on the picture of the graph is it looks like it comes really close together here and just touches, like the parabola comes along closer and closer and closer, touches the line and then leaves the line. You know, kind of like the line just is touching. Guess what? Oh, I got a word for you. Got a cool word for you. That word is tangent. We used it in geometry, and they're going to use it in calculus. When a line is tangent to a curve or touches a curve in a single spot. All right. Just like when you did in geometry class when you had a line or line segment that touched a circle in a single spot. That was called tangent. Okay. Let's see what else we got here. All right, so continuing to solve. Whoops, I dropped my stylus. I better grab it. So we shall place this in that spot right there. 6x squared plus 14x plus 4 equals 3x plus 1. And of course, we're going to push everything over to one side, setting it equal to 0. That's subtracting a 3x and subtracting a 1, right? So we got 6x squared plus 11x plus 3. And we do the b squared minus, all right, step number 1, b squared minus 4 times a times c. 121 take away, let's see, what is that? 24 times 3 is 72. Okay, 121 minus 72. Well, if I take 121 and I take away 70, that would be 51. And then if I take away 2 more, that's 49. Interesting. And then, of course, part 2, we've got x equals the opposite of b all over 2 times a plus or minus the square root of 49 over 2 times a. So that's a negative 11 over 12 plus or minus 7 over 12. Well, let's see here. Negative 11 plus 7. That's negative 4 over 12, which is negative 1/3. And then what's the other one? Negative 11 minus 7, that's negative 18 over 12, which is negative 3 divided by 2. Ooh, that's pretty ugly. So now we have 2 coordinate answers with negative 1/3 and negative 3/2. Okay. Now I need to find the y values that go with it. I'm suggesting that we probably should use the linear function. That'd probably be the easiest in my opinion. 3 times negative 1/3 plus 1. And then also 3 times negative 3/2 plus 1. Well, the first one, the 3's cancel out, giving me negative 1 plus 1, which is just 0. So that's kind of easy. And then, let's see here. Negative 9 over 2 plus 2 over 2 is negative 7 over 2. Negative 7 over 2. And those are the solutions to the system. Just have to plug them back in. They're ugly, I get it. Since those are nice decimals, you could probably give me decimals. But anyway. Andrew kicks a ball up a hill for his dog, Leica, to chase. The hill is modeled by the line through the origin. The path of the ball is modeled by the quadratic function. Write and solve a system of equations to represent the situation. Obviously, they want to know where they're equal, so they're just we're just doing the substitution thing we've done before. So we're going to put 0.5x on one side and the negative 0.5x squared plus 6x on the other side. Of course, you want to push this to the other side by subtracting 0.5x, which would give me negative 0.5x squared plus 6.5x. Oh, no, that's not 6.5, that's 5.5. Duh. Can't be making mistakes like that. So, b squared minus 4 times the a value. And the c value here is 0, so that's kind of nice. So this is really 5.5 squared. I'm going to grab a handy-dandy calculator because that doesn't seem like a nice thing. 5.5 squared. Oops. 30 and a quarter. Okay, 30.25. I wonder if that's a nice number. 32. Oh, that is. That is. It's the same thing as saying 30 and 1 over 4. If you do the trick where you take 30 times 4 and then add the 1 on the top, you get 121 over 4. Now, I might have a reason why I'm doing that. But I'm guessing you wouldn't have a problem seeing it. I should probably do step 2 over on the side. Step 2, because, x equals the opposite of b all over 2 times negative 0.5 plus or minus the square root of. Now, if you put that 30.25, or if you really want to put the fraction in there, you're going to get 11 halves or 5.5. Because 30.25 is the square of 5.5. 2 times negative 0.5. So let's see here. The bottom is negative 1, so we have 5.5 plus or minus, and then negative 5.5. Whoa. So one of those answers is going to be 0. The other answer is going to be 11. Now, 0 was the time right when the ball was kicked. Ball kicked here. Ball lands here. Now, wait just a doggone second. Is that really true? That's 11 freaking seconds? Did I do something wrong? Opposite of b, or b squared minus 4 times the a value times the c value. Okay. Opposite of b over 2 times a. Is that really true? Yeah, okay. That doesn't seem really right. I mean, you got a ball in the air for 11 seconds? Holy cow. Or is that right? X is horizontal distance. Oh, that makes more sense. 11 feet. Holy cow. I was thinking it was time. I was like, man, that is not happening. Yeah, 11 feet. So it's 11 feet from the starting point. And the y value, let's see, that would be y equals 0.5 times 11, which is 5.5 feet. So the vertical distance from the start is 5.5 feet. The horizontal distance is 11 feet. How far does the ball travel horizontally? 11 feet. How far must Leica run up the hill to catch it? Oh, now that's an interesting question. Because truthfully, we have 11 feet and 5.5, but Leica the dog is traveling along the hypotenuse. Ooh, interesting question. 11 squared plus 5.5 squared, and then take the square root, a little Pythagorean theorem. All right. 11 squared plus 5.5 squared, take the square root, equals 12.3, approximately. So she has to run 12.3 feet to get there. Interesting. I like that question.